Hi all, welcome back. So in today's video, from seeing the slide itself, you can understand we are going to talk about System Verilog Testbench architecture code. Okay, so coming to System Verilog Testbench code, it is entirely different from that of Verilog code. Why is it? Because if you are already familiar with Verilog coding, then you understand what I am trying to say. Basically, in Verilog, when you are writing the test bench code, you will have only one file where you will be writing your, where you will be passing the values in only one file, which you will be connecting to your dut. Is it or not? But that is not the case in the case of system verilog. Why is it? Because system verilog is mainly designed in order to verify complex designs, and also system verilog is enhanced, having many enhanced properties which makes it unique for verification side. That is why in system verilog, in order to write a test bench code, you will be using lots of components and lots of enhancer concepts that you study in system verilog. Like you will be using oops concept, you will be using randomizations, you will be using constraints, you will be writing assertions, you will be seeing coverage. So every concept that you study in system verilog, you will be putting into action when you are writing a test bench code. Okay, so the reason why I am explaining the code without explaining, without talking about assertions and coverage is, for a basic code, if you are a beginner and if you are learning system verilog from basics, okay, you just need to know how you will be developing your test bench code by using the basic concepts like oops concepts, randomization, okay, and constraints. So by using all the techniques like mod ports, mail boxes, so by using all these things, how you will be developing a base test bench code, you will be seeing it in today's session. Okay, if you are new to this channel, please consider subscribing the channel and hit on the notification bell also. Right. So in today's topic is System Verilog Test Bench Architecture Code. Okay, so before going into code, let us first have some basic talk about the System Verilog Test Bench architecture. I think you already know about the System Verilog Test Bench architecture. I have clearly explained about the System Verilog Test Bench architecture many days before. I'll link that video in the description box or in the title. You can just go there and check it out. Okay, so now coming to this test bench architecture. Okay, when you are developing a code or while I am explaining a code, we can do it in either top down manner, or we can just start it from test bench and we can go to the inside components like generator, driver, scoreboard, monitor, etc. Or else there is another way in which I will be explaining from bottom to up. Like means we will be starting from the basics and then we will be going for the test bench top. Okay, so when you see this architecture, you can understand that this is a transaction. Transaction is nothing but some packets of data. Okay, that means whatever input data that you are sending to the DUT, that is called the transaction, nothing but packets of data. So this packets of data is present in your transaction code, okay, which you will be sending to the generator, and from generator it will be going to the driver. Okay, from driver. So if you see here, the transaction should be present in generator as well as driver also. Okay, so what should be the generator consists of? It should consist of transaction packets, nothing but packets of data, and along with it, it needs to carry the information from generator to driver. So what does it need? It needs something to put the data and get the data. So you are using the mailboxes concept here. Clear? So the generator should consist of transactions as well as some mailboxes and the remaining things. Now coming to driver component. Now what should the driver consist of? It needs to have transaction. Okay, and then it needs to get the transaction from generator. So it needs to have mailbox. And along with it, it needs to have interface. Okay, So I have explained interface clearly here, but interface interface by nature is static in nature. But if you see the generator, driver, monitor, scoreboard, these all are oops components. Okay, these all work on the oops concepts. So oops inbuilt is dynamic in nature. Now, if you want the static interface to communicate with driver, which is dynamic, then you need to create a virtual interface in the driver, which will be communicating with the which will be useful in order to communicate, in order to transfer the information from driver to the DUT. Okay, so the driver consists of interface which is virtual in nature, transactions, mailboxes, and the remaining things. Clear? So this is the thing of for the driver. Now what should the driver do? It will be sending the transaction to the DUT through interface. Now what should the interface consist of? As you already know, since I have explained clearly like what is interface and what is the need of interface. If you didn't check that video, you can go to my channel. I'll link that in the description box, like interface, what is interface and all. You can go there, check it out. So interface consists of all the input and output signals, like it is just like a bus where all the signals are packed at one place. So that is the thing that interface should consist of. Now the DUT is nothing but the RTL code. So basically, now from DUT again it will be sending the output which is given as input to the monitor. So if you see here, what should the monitor consist of? Again the monitor should consist of virtual interface, transactions. Okay, so it needs to get the information from DUT. Again it should consist of some mailboxes. Okay, now what happens? The monitor, after displaying everything, it needs to send the transaction to the scoreboard. Why? Because in scoreboard the checking like whether everything is correct, like whether if you are writing some test cases or if you are doing something, whether the input and the output is correct. Okay, basically in scoreboard what happens means it will be checking the expected data and the actual expected output and the actual output. So what is the output that the DUT has sent, like the monitor has sent to you, is the actual output. And the expected output means when you are designing something, you will be expecting the output in some way. Is it or not? So these two, the comparison will be done in the scoreboard. Okay, theoretically, but you will be seeing how you will be comparing that with the in a form of code, right? So now if you see, this is the work of the scoreboard. Now if you see, the generator, driver, scoreboard, monitor is all encapsulated in the environment. So what should the environment code consist of? It should consist of generator, driver, monitor, scoreboard, everything, transaction. So the encapsulation of entire all these components should be present in environment. Okay, and also environment, and then within the environment. So this entire environment is there in the test. So test is nothing but test cases. So basically, test cases are nothing but, for example, uh, if you are designing some adder circuit, which we'll be explaining later, like in the few minutes, when you are writing the adder circuit, you will be having test cases like how many times the transaction should happen, how many number of transactions that you should send. So basically you will be having only one test case. What is it? You need to send the two inputs and you will get the output. That is only one test case. For example, if you are designing more extra components like memory. Okay, if you are considering the memory, when you are designing the memory, there you will be having two test cases. Like you need to write the test case for reading the elements, or else, or you need to write the test case for writing the elements. Okay, read from the memory or write into the memory. So you need to write two test cases. So in this way, based on the design you are choosing, your test cases will differ. Test case is nothing but what are you going to test? Simple. Okay, what are you going to test? You will be writing it in the form in the code in the test case component. Okay, so this is about the test. Now after this test, the entire thing is you will be going to connect it with the test bench top. Okay, so what does your test bench top consist of? Basically, when you see the Verilog code, what you will be having in the Verilog test bench code, if you are designing some sequential circuits, okay, if you are designing some flip flop or else something, okay, and if you want to write a test bench code for your flip flop, what you will be having? You will be writing the clock, you will be writing the reset. So, what are the signals that are in general needed for all these components, like clock signal, reset signal? So all these connections, they will be present in the those will be present in the test bench top. Okay, so these are the things that you are going to expect in your code. Now let us see. I'll just In today's video, I'll just give you a brief introduction of the your Verilog Testbench thing, because since you have already, if you are someone who are following my videos regularly, I think you can understand most of the concepts, that why you are using them and why you have introduced them. Since if you are following my videos and you understand everything, every concept in system Verilog, now it is easy for you to understand the Testbench architecture code. Okay, in today's video I'm going to give you a brief introduction on all the concepts, and in the upcoming videos I'll be explaining every module, like every component, like generator, what are we going to place within the generator code, what are we going to write in the driver code, why should we write in that way only, what is the need of monitor, and what are the things that we need to write in the monitor. Everything in detail I'll be explaining it in the upcoming videos. But for that, what you need to do is, if you like this video, please do like it and also share it to all the VLSA aspirants. Hope it may bring some helpful. It is helpful for at least some of you who are interested to enter into design and verification domain. Right now, let us go to code. So let us see the code now. Okay, so this is my code. So this is my test bench code for adder. So this is my DUT. So basically DUT is same either in Verilog or system Verilog. The RTL code is going to be same. You can write it in any ways you like. So basically, even though it is a simple adder, since I am using it, I am going to test it, or I am going to develop it in the system Verilog. So obviously I need the clock, reset, and two inputs, IN1 and IN2, and along with it one output. But along with these two inputs and output, I am again adding two control on that adder. Okay, like valid input and valid output. If there is only valid input, then only you will get the output. So that is why, in order to put some more control on my adder, I am including some more extra input which is valid in, and then the valid out. So these I'll just mentioning what are the inputs and what are the outputs, and then I'm just writing the code. So what is my code? For every positive edge of the clock, if there is reset, if reset is there, then the output and valid output will be, instead of any garbage value, it will be having some zeros. Like if there is reset, before resetting, you will be having some any garbage value, and after resetting I'm making everything to 0. Now if reset is not 1, that means if there is no reset, then the output will be in1 plus in2. So if you see here, this is non-blocking assignment, because in order to avoid any race around conditions, you mostly prefer non-blocking assignments in any system Verilog test bench mostly, but not entirely. Okay, just keep that in mind, right? And then I'm just including valid output equal to valid. That means only when there is valid input, then only there will be valid output. Okay, so in order to give that in a logic manner, I'm just writing it like this. So this is my basic adder. You can write it in any way you like, but I'm just making it like this. Now the first thing is, you should have a transaction. Okay, so what the transaction should consist of? It should consist of all the inputs and outputs. Okay, output. So if you see here, what are the inputs? IN1 and IN2. So it is of 5 bit input and 5 bit out, 5 bit 2 inputs. Okay, and a single bit valid input. Okay, so valid is either 0 or 1 basically. If valid is input only, then only the valid is 1 only, then only the IN1 and IN2 are correct inputs, so that you will get the correct output. So I am taking the out as 6 bit. Since it is 5 bit, obviously, since it is added, you will be getting extra, so 6 bit wait. Now, valid out. Now, if you see here, all the inputs are rand bits and all the outputs are not rand bits. Why is it? Because input signals need to be randomized. Output signals should not be randomized. Why is it? Because if you are getting the random output, then that is not the correct output, is it or not? So, never make the outputs as random. You should be using only rand for inputs. Okay, so you know what is the use of this rand. Okay, this is the rand keyword in order to make the randomization happen on this particular in1, on this particular in2, and then I am writing some constraints, okay, for my valid input. So because I am telling the valid input, so what is the meaning of this valid input? Okay, what is the valid input and what is the valid output? I need to write the condition, right? I'm just saying that everything is valid input, then what is the need of putting the control on it, is it or not? So in order to put a control, I need to put the condition. So how can you make the condition? By using constraints. So what is the valid in dist? So this is the weightage distribution operator in constraints. I have already explained clearly about this dist in system Verilog. I link that also in the description box. You can go there and check it out to just refer, like in order to have just some brief knowledge on this dist. So what does this dist operator do? 1 semicolon equal to 3, 0 semicolon equal to 1. That means when the randomizing is happening for this valid in, okay, so for every randomization, 3 times you can, if you are randomizing for 5 times, in those 5 times at least 1 should exist for 3 times and 0 should exist for 1 time. So that is the condition I'm writing. So that means at least the input should be in this way. That means valid inputs means valid in should be 1 for at least 3 times. When you are randomizing valid for 5 times, valid in should be 1. That means the correct input should be coming for more number of times, and valid in is 0. That means it is on or off condition. Is it okay? I think you got it. Switch should be on for at least 3 times and it should be off for 1 time. In that way, I'm just putting the condition for my valid input, and then I'm going to write a function for in order to print all the input and output cases in my system, in my particular transaction, in a function named print. Okay, this is what the transaction consists of basically. So as I already told you, it just consists of all the inputs and outputs, and if you are adding any control, the constraint for that control in your transaction. Clear? Now this transaction is taken by the generator. So what does the generator do? What should the generator consist of? It should consist of transaction. So the transaction file is included, and then the transaction handle is also created. So this is my transaction. Okay, for my transaction I have created the handle. Okay, so it is just like whenever I want this particular transaction, I can use this handle. Okay, and along with the transaction, it should consist of mailbox in order to put the transaction from generator to driver. So mailbox. Along with this mailbox, it is having some other int variables like tx count. Okay, like why? Because you are having transactions, right? Number of transactions will be coming, so it needs to count how many transactions I have completed, how many transactions are come in this way. It need to count the transactions. So I'm just adding the variable tx count. In this way, some events also I have added. Okay, so along with the I'm using my writing the code. This code I'll be explaining in detail in the next upcoming classes. But this is the thing that the generator consists of. See, the rand bit, which is random transactions need to be coming, and then the mailbox. Okay, mailbox name it gen to drive because it is transferring from generator to driver. Now along with the generator, let us see the driver. Now what should the driver consist of? Obviously driver should consist of the transactions. Okay, so here, since I have created the transaction count, so based on the transaction count, okay, it will be coming like transaction count 1, transaction count. I am taking two variables, and along with it I need to have a virtual interface in driver. Okay, so I'm creating virtual interface with virtual keyword. Okay, so this is my intf is the name of the interface. Okay, for this interface I am creating the virtual interface named intvifvi. Okay, so this is the handle of my virtual interface. Along with it, it needs to consist of mailbox. Okay, so I'll be creating some memory like constructor function for this virtual interface and mailbox, and then the actual data that the driver consists of. Right, this is my driver. Now comes the interface. Now, if coming to the interface, what is happening here? Interface here, if you see, as I told you, interface consists of all input, output, clock, everything. So this is what. So whatever inputs, if you see here, whatever inputs that are present in your DOT, everything you are packed within the interface. So whenever you want to use all the signals, instead of mentioning every individual name of the signal, you can just use the interface handle INTF. Okay, so this is about the interface. Now I am writing the monitor. So here there is a logic, just like how you are generating, how you are developing your DUT code in different manners. Similarly, you can write your test bench code also in different manners. Since here I just mostly, if you see in any test bench adder, like adder SV test bench, you will be having only one monitor like a file. But here, if you see, I have included two monitor files, where one monitor file consists of all input signal. So all the input signals will be displayed in this monitor file, and all the output signals will be displayed in one monitor file. You can just include everything in one monitor itself. There is no problem in that. But in order to segregate, I have done this. So what should the monitor consist of? Obviously, the virtual interface mailbox. Okay, right? So these two, because the transaction has gone to DUT, and the DUT will be sending the information, okay, through virtual interface. So that is why it should consist of virtual interface. The DUT will be putting it in the mailbox. So through mailbox also, it needs to have mailbox, so that it will be keeping it to scoreboard also. Right, so this is about the, again it will be having some constructor function and some logic. Okay, this is, if you see, all the logic is related to inputs only, in1 in2. Okay, but here if you see monitor out, here the logic is entirely on out. Okay, you can just include these two logic in one monitor and you can write it. There is no problem in that. But in order to segregate, it is done. I'll explain that also, like how with one monitor how you are going to write. I'll be explaining that also, don't worry about it. Now coming to scoreboard. So what does the scoreboard consist of? Obviously the mailbox. What is the mailbox? Since I'm having two monitors, so basically two scoreboards here, two mailboxes you need, because all the inputs will be sent in one mailbox, all the output signals of the monitor will be sent in one mailbox. So obviously two mailboxes you need to have, and then the logic for this particular scoreboard. Okay, for comparison and all everything. Right, so this is about the scoreboard. Okay, don't worry about the in detail explanation. I will explain every component in detail in the upcoming sessions. Don't at all worry about it. Now coming to environment. So all these components, as I told you when we are discussing about the architecture, are present in this particular environment itself. So what should the environment consist of? It should consist of generator, driver, monitor, two monitors. So obviously monitor in, monitor out, and scoreboard. So these are the basic four things that are present in the environment. Okay, and then if you see class environment, so within this I'll be creating the handles for all these four components. Okay, so all these four components, again all these four components consist of mailboxes, right? So all the mailbox, so the origin of all these mailboxes, the origin of all the handles, mailboxes, these all will be present in the environment. Okay, when we are explaining from top to bottom, basically this is where the entire origin takes place, and from this you will be taking the handles and you will be using it in your particular logic that you are writing within the driver, monitor, interface, and everything. Right, so this is the thing. And then you also obviously need the virtual interface, and also the memory locations. As I told you, the origin is happening here, so that is why the memory allocations and everything is done within the environment. Okay, and then the some like test case running. As I told you, you will be running the tests. Okay, so in order to run the test, you will be writing the code for running the test, pre-test, test, post-test, everything, running the test, running the values, everything you will be doing here itself. Okay, within the environment. And now coming to test. So test case, as I already told you, since this is the basic adder, you will be having only one test case. Okay, which will be consisting of, here if you see, the text case is nothing but the test case. What should it say? It test, it will be testing all the transactions. So how many transactions, so what should it have? It should have the logic related to how many transactions have gone into that particular DUT, and is the are those any valid like transactions and everything. So it should need to count the test count. So that is why tx count is equal to 100. This is the only thing for, since it is an adder. But if you are using memory, you will be having two test cases, like you will be using write test and you will be having the read test in this way. Okay, read test and write test, you will be having two test cases. I'll also try to explain the memory also in my channel, because many of you are requesting me explain the test bench code architectures of system Verilog. That is why I try to explain memory also. Don't worry about it. So this is my test. Now finally coming to test bench top. So test bench top is nothing but this, here basically you are having interface as well as test. Okay, if you see in the architecture. So these are the two things. Now if you see, as I already told you, test bench top is nothing but the signals which are most commonly used by all the components within the particular architecture. You will be having those. So basically in this test bench you are having clock and reset. So these are the two signals, so that is why most commonly used. So that is why you will be initiating this clock and reset signals here. And then coming to interface, you will be instantiating the interface also here itself, and then test cases instantiation. And here if you see, this is the connecting, you are connecting your DUT to the SV test bench architecture by you. Here in the test bench top, you will be connecting the DUT to the TB. Okay, adder TUT, the entire thing. If you see all the signals, you will be with the help of interface, because you have used the signals in the interface. Okay, so that is why you'll be instantiating all the signals with the interface of top handle. Okay, and then you will be writing the dump file. So basically in order to see the signal, you will be using this file. Okay, dump file is nothing but in order to see the waveforms. Okay, because basically when you run this code on the log file, you can see, you don't if you can see only the outputs, but when you want to see the waveform of that signal, you will be using the dump file. Okay, so this is the basic code for system Verilog. In the upcoming classes, I'll be explaining deeply about what is there in generator, what is the code for driver, how we are going to write the code for generator, driver, transaction interface, and everything. Right? So if you like this video, please do like it, and also please do share this video to all the VLSI aspirants. That is all. Thank you.